Here we have use of comparison test for checking if the series are convergent or divergent. So let's work on some examples to learn this. First one is 9 power n 3 plus 10 power n. Goal is to come up with a new series which you know about and you can compare to this. Okay, so let's name this series an. So I need to come up with another series bn. So I'm gonna kind of get the hint from the original series and think that Bn is 9n by 10 the power n. Okay. Now, if you guys notice, this one is a geometric series, first of all, right? With common ratio equal to 9 by 10, absolute value of which is less than 1. Therefore, we know that Bn converges. Okay. Remember, to use comparison test, we should have positive term series. The series is positive already, so we don't have to worry about that. That condition is satisfied. Okay. So let's work on the comparison. We know that if we have this fraction for any n and this fraction for any n, what do we see the difference between these two? The denominator of the first one is larger. That means you're dividing by a larger number than the second one, right? So that means when you divide by a larger number, that number has to be smaller than when you divide by a smaller number. Okay, so this number is smaller than this for all n. This is true for all n. Therefore, we can say sigma an series is smaller than sigma bn and sigma bn converges. We know that because that's geometric. Therefore, using comparison test, sigma an, which is 9n by 3 plus 10n, also converges. Because if this larger series converges, right, then the smaller series should also converge using the comparison test. Let's work on this one. This series, let's name this series an. Let's talk about one term of the series n minus 1 divided by nq plus 1. Okay. Now, let's work on one step at a time. N minus 1 is smaller than n. Therefore, n minus 1 by nq plus 1 is less than n by nq plus 1 because you're dividing the smaller number with the same number. So, the first thing should be smaller than the second one. Now, in the second one here, the denominator is nq plus 1. But what if the denominator was nq? If you divide by a larger number, this thing should be smaller than this thing because you're dividing by a larger number. So, and this thing is equal to 1 by n square. So, we are claiming basically that n minus 1 by nq plus 1, which is the given series, is smaller than 1 by n square. Therefore, the second series which we need to think about is 1 by n square. And that one is P series with P equal to 2, which is more than 1. Therefore, this is convergent. Okay, one more time. We have sigma an is smaller than sigma bn and the larger series converges. Therefore, using comparison test, the given series sigma an, which is n minus 1 by n cube plus 1, also converges. Pay attention, this comparison test is applicable because the terms are positive here, right, for most of the terms. So positive term series comparison test can be worked. You only need to come up with another series about which you know, and then show the comparison, and then you can write the answer.